get started. Today is our last day for any new work, and we're going to finish off antiderivatives. And if you look at my new updated, hopefully slightly neater list, I've added a few more guys because we need them. The antiderivative of 1 over 1 plus x squared is the inverse tan. This 1 over weird square root is the inverse sine. And if you stick a -1 on top of it, you get an inverse cosine. And so pretty much this is inclusive. So let's jump right in and do some more antiderivatives. So if you want to find the antiderivative of this fraction, you've got to turn everybody into pairs of x. And we did a similar one yesterday. And one of the easiest, I think, ways to tackle this question is to think of this x squared as being a multiplication by x to -2. And then you can distribute all the way through. Now, if you do that guy times that guy, you end up with 7. Because an x squared and an x to the -2 gives you x to the 0, which is essentially just 1, and 7 ones are 7. Now, if you do this one, you're going to get 2x to -1. And if you do the last one, you're going to go, and you're going to get that. We have to be really wary about this very special case in the middle. The power rule does not work for that guy. It's the only guy it doesn't work for that's a pair of x. So I'm going to rewrite it like that. So all we've done is take the original fraction and convert it into 3 individual terms, which we should now be able to integrate. Because the number 7, when you integrate it, gets you 7x. This is the special case. That gets you -2 natural log of x. And this guy is the power rule. So I'm going to add 1 to the power and then divide by the new power. So technically we get that. And then I'm going to make it look pretty, which really isn't going to be that much. That's us finished. The antiderivative of a fraction, a rational function, should be converted into powers of x using this technique. If there's any powers of x that end up being -1, treat it as a special case. If there's not, that's fine. And then you can integrate each piece using either the power rule, or if you get a 1 over x, by a log x. And then remember to stick the plus c, the RBG constant, and you are done. So next fella in the list. I had them up here. I hope I still do. I do. Okay. So where are we? Version 13. All of those guys belong here. So you take each one and you integrate it using its antiderivative. So capital F of theta. 3 cosines become 3 sine thetas. What will -2 secant square thetas get you? What is the antiderivative of -2 secant squares?
-2 tangent.
There you go. And 5 secant tangents just get you 5 secants. And then just remember to finish with your plus c. It's much better. I know it's a lot. It's a bit like learning French, I guess, where there's a whole load of words and you have to remember what they are in French. But memorizing these guys just makes this job 10 times easier than if you're ever going to go, what's that one and this, right? Kind of breaks the flow, breaks the mental flow. This is a version of question 14. Well, before I try and find the antiderivative of this function, there is one expression, this guy, who needs to be rewritten. Right, I have to write it in a different way. How will I write the square root of x cubed so that I can use one of these guys here to get its antiderivative?
X to the 3 halves.
Right, so every square root, cube root, fourth root, you know, those kind of roots, every 4 over x cubed, 7 over x squared, 3 over square root of x, all the guys that look like that, turn them all into something that's a power of x. Do you recognize that guy? What's the antiderivative of that ugly fraction? It's over here somewhere.
2 times sine inverse.
Okay, 2 inverse sines. Do you recognize that middle one as an inverse tan? And this guy is just an ugly power rule. So I'm going to add 1 to the power, and then I'm going to divide by the new power, and then finish with a plus c. And the only thing I need to do here is some style points, which is really quite minimal. And it's to turn that guy into that. And we're finished. So as long as I give you linear combinations of any of these guys, you should be able to find the antiderivative by using these guys. That's essentially the process. Any questions before we move on to the last piece of the puzzle? We good? Okay. Here's an example of the last situation. We're given a function, nothing too amazing about it. And we're being asked to find f of x, which again is not that amazing. And there's a bit that's going to come later. I'm going to pretend for now that they didn't have it. So if I just said find the antiderivative, 2e to the x just gets you 2e to the x. This guy is a power rule. So you add 1 to the power and divide by the new power, you get that, plus c. And that is our antiderivative. We do not know what c is, right? That's why we put plus c. But what they do in this group of questions is they tell you one extra piece of information. In this case, f of 0 equals 4. Now with that piece of information, so they actually have 2 names for this. Sometimes they're called a boundary condition. They're sometimes called initial values. So they'll tell you a boundary condition like f of 0 equals 4. And what you then can do is use that to figure out what c is. How can I use this to figure out what number c is?
Couldn't you just solve for 0 and
Yeah.
put it equal to 4?
Sounds good to me. So f of 0 is 2e to the 0. Take away 4 lots of 0 squared plus c. And we know that's equal to 4. E to the nothing is 1, so that's 2, take away nothing, plus c equals 4. And solve for c, well, take 2 away from both sides and you got 2. And so we now know everything. The antiderivative is 2e to the x, take away 4 squared, plus 2. And that would be your final answer. You like that? That if you tell me a boundary condition, we can actually find out who C is, right? What number it is. Now, take that idea and just do a little bit more with it. So this is question 17. Sorry, this is 17. Where's the guy I want? 21, my apologies. I'm jumping around. Yeah, take that idea, let's just go with it. Suppose I tell you the derivative is that, and the f of 1 is 13. Now, right at the beginning, antiderivatives, didn't we tell you the two notations? One of them is this guy. They tell you who the derivative is, and your job is to find f of x. Isn't that just another way of doing antiderivatives, right? Just another way of showing you. So, add 1 to the power and divide by the new power. 1 over x is a special case. You get log x plus c. We'll then use this boundary condition to find out who c is. So f of 1 is 4 times 1 to the power of 4 plus the natural log of 1 plus c, and it should equal 13. Well, that guy's 4. What's the natural log of 1? What number is it?
0.
Yeah. So we get 4 plus c is 13. So that gives me 12. So we now have the antiderivative. Are we comfortable with this working backwards? Finding antiderivatives. Let's do another one. Suppose you're told the derivative. I've just done that one. Try that again. And there we go.
For the C, did you just do 13 minus 4? Or
And I said 12? Good
yeah.
grief. Did you all catch that deliberate mistake, everybody? Does anybody believe that was a deliberate mistake? Yeah, that's good, because it wasn't. Okay, got this guy. And in question 22, you are being told that is my boundary condition. Oops. So it's not here, you can't see it, it's under this piece of paper. So this is basically memory. What does a 1 over 1 plus t squared antiderivative look like?
Inverse tangent?
There you go. Now we'll use our boundary condition to find c. F of 1 is 16, that one? Yeah. Inverse tan of 1 plus c, and that has to equal 0. Now this one I'll test you. It's not that long since you've done pre-calc 2 trig. In radians, because that's what calculus deals with, just radians all the time. What is the inverse tan of 1? What angle is it? So it's basically what angle has a tangent of 1. Any takers for that one?
Pi fourths. And 7 pi fourths.
Yeah, we always take the first one, so that basically pi fourths. Now that gets you 4 pi plus c equals 0. So c is basically negative 4 pi. And so we are finished. The antiderivative f of x is 16 inverse tans minus 4 pi. Are we doing good? Happy with this process? Find antiderivatives and then use an extra piece of information, the boundary condition, to find out what C is. So we've got one more of these to do, and then we take it a little bit deeper. So the last one of that particular kind looks like this. What are we going to do about antiderivative of an ugly fraction, x plus 1 over the square root of x? I can't leave it like that, because if I do, I don't know how to find its antiderivative. What will I do about it?
Move the x to the 1/2 to the top, and then multiply through.
Okay, so the square of x in the bottom becomes a multiplication by x to the negative 1/2, which gives me x to the negative 1/2, sorry, x to the plus 1/2, and x to the negative 1/2. That times that gets you plus 1/2, that times that gets you negative 1/2. And so we can now do the antiderivative. Add 1 to the power and divide by the new power. Add 1 to the power. Dividing by 1/2 is basically multiplying by 2 plus a c. Then do style points. And lastly, use the boundary condition to find out what c is. So f of 1 is 2/3, 1 cubed, plus 2 times square root of 1, plus c, and that's going to equals 4. That guy's just the square root of 1, so that's 2/3. That's plus 2. And all I need to do is subtract 2 from both sides and subtract that from both sides, and you get 4/3. And so our final answer is the antiderivative is that guy plus that guy plus 4/3. We're finished. So how can we make this even weirder? Well, let's do a little side issue. Suppose I tell you the second derivative, which is why this notation can sometimes be better than the capital F of X notation. Suppose I gave you that guy, right? And he's going to be equal to 2x plus e to the x. And I asked you to find that. And we're going to use antiderivatives. In other words, we're going to undo differentiation. Undo. If I take the antiderivative of a second derivative, would you agree you get a first derivative? Would that make sense? Undo a second, you get first. And antiderivative of that guy is x squared, and the antiderivative of this guy is e to the x plus c. That's fine. Now, if I take the antiderivative one more time, don't I get the f of x that we're being asked to get? Power rule. Add 1 to the power, divide by the new power. Power rule. Oh, now we got to think about it. That is there, right? We don't ignore it. It does say plus c. That represents an unknown number, right? Plus 8, plus 48, right? We don't know what the number is, but it's there, right? It's a plus c. What's the antiderivative of plus c?
Plus CX.
Yes. And a lot of people quite understandably say, hey, that wasn't too bad. But there's something missing. When you take an antiderivative, don't you create an unknown constant? So I need another different unknown constant. Now, you notice I'm calling this one plus d. Why can't I just say plus c again? What would be wrong with the logic of saying that?
It could be different numbers.
Yeah, they could well be, probably are different numbers. So c and d is that, and that's it. Now, suppose we do, let's go crazy, a third derivative. And we're going to make it the square root of t, take away 6 cosines of t. By the way, this is question 20. Well, before I even think about doing antiderivatives, I'm turning that guy into a half power. Okay. And for some reason, I'm making my letters all weird. Everybody's a T. Right, antiderivative. Add 1 to the power, divide by the new power. If you want to find the antiderivative of a cosine, the answer is a positive sign. So negative 6 cosines will get you negative 6 sines plus c. I'll do an antiderivative again. So now it's the first derivative we'd get. Now it gets a bit messier, but add 1 to the power. Now dividing by the new power 5/2 is the same thing as multiplying by 2/5. That's why that is now 4/15. You happy about that? Dividing by 5/2 is like multiplying by 2/5. If you multiply this by 2/5, you get 4/15. What will the antiderivative of negative 6x get you?
Positive 6 cosine.
Correct. Because a sine gets you a negative cosine. So 2 negatives make that a plus. Now the c gets you c it, but there I go and put x's again, gets you ct plus d. And one more time. Add 1 to the power. Now you've got 7/2. Divide by the new power is the same as multiplying by 2/7, which is why that is 8/105. If you find the antiderivative of 6 cosines, you get 6 sines. Oh, now this one's going to be a bit sneaky. What happens to CT when you find its antiderivative? What's the antiderivative of CT?
1/2 CT squared.
Would you all agree? Add 1 to power, divide by the new power. And that is totally correct, except that's not what we write down. Now, it looks like I'm writing down nonsense in a kind of sort of a way I am, but it's acceptable nonsense. This here is a half somebody you don't know, t squared. This guy is somebody you don't know, t squared. Aren't they exactly the equivalent to each other? Now, the fact that I keep calling that C, if it made you feel better, can we call that one C1 and call that one C2 if it makes you feel better? But we just call it C. Are we good? A little hiccupy? We don't write a half C squared because there's no need to. So this one's going to be C t squared. And the D is just going to get me dt. And we're finished. So if you have, if you have CT cubed, right, just for example.
Do we need to add another constant letter on the end? Or-
You're right. You need to add in an E. Almost missed it. Too busy thinking of this. If you found the antiderivative of this, it would be t to the 4, right? And then divide by the new power, you get that. But we just call that guy, if it happened, CT to the 4. You see the little, you know, if you don't know what something is, a quarter of it doesn't help. Would you agree it's just somebody you don't know? And it's just prettier, right? It's just style points. Right, let's put that whole package together, i.e. multiple derivatives and finding the missing guy. So the last question for today, perfect time, 25. It's going to be sine of theta take away cosine of theta. And our boundary conditions are going to be I rewrite this. My eyesight's not as good as it should be. It's only a second derivative, not a third. Right. Second derivative is this. And we have some boundary conditions. F of 0 is 2, and f dashed of 0 is also 2, at least in my version. Okay, find the antiderivative for the first time. Well, if you do the antiderivative of sine, you get negative cosine. And the antiderivative of a cosine is a positive sine, so you actually end up with that plus a c. And then you have this piece of information, which I'm now going to use. That the first derivative at 0 is negative the cosine of 0, negative, that's a 0 by the way, negative the sine of 0 plus c, and that should equal 2. And my cosine of 0 is 1, so that's negative 1, take away 0, plus c is 2. -1 plus c is 2. That makes c equals 3. So we can now write down the full version of f dash theta. It's a negative cosine theta, negative sine theta, plus 3. So far, so good. Right, antiderivative. The antiderivative of a cosine is a sine, so a negative cosine will get me a negative sine. The antiderivative of a sine is a negative cosine, so a negative sine will turn it into a positive cosine. The antiderivative of 3 is 3 theta plus a guy I don't know. I'll now use this boundary condition. F of 0 is negative 2 times the sine of 0 plus the cosine of 0 plus 3 times 0 plus d, and that has to equal 2. Nothing plus 1 plus nothing plus d equals 2. A little bit of working on it. D is 1. And we finally get our answer, that it's negative the sine of theta plus the cosine of theta plus 3 theta plus 1. We're done. And this is, to me, the kind of the sad part. We're finished. There's no more to learn in Calc 1. So we are going to be working tomorrow on revision for your final. And I expect you to be here because it's a normal school day. Next week, Monday is a school day as well, but Monday's going to be a little bit different. You will be given attendance for Monday. Whether you turn up or not, you will get participation. I'll assume that if you don't turn up, you're just studying for your final anyway, so it's not like you're wasting your time. If you do turn up on Monday, it's very open-ended. You might just turn up on Monday and say, I need help with this. Implicit differentiation. Okay, I've got it, bye-bye. Right, so you just drop in and leave. You can come in and watch everybody else's questions and add a couple of your own, for the whole period. You can drop in the middle, leave halfway through. Anything's wrong, right? Open-ended. Really. I want to make it as useful as I can, and that's how we're doing that. So Friday's a normal day because I want to tell you all the details and I want to make sure that you're here for that. But the following Monday is really up to you, how much time, if any, you spend with me. Okay. So here is our question. When is the final?
Wednesday.
Okay. What time is the final? He's correct.
7 a.m. to 10 a.m.
Right, you all got that? Now, did you notice it's 7 a.m.? Do not come to class at 8 thinking, I just assumed it would be 8 because that's when our class is. Because if you do that, haven't you just wasted 1 hour of time that you could be doing your final? So set your alarm early on Wednesday and we will be good. Okay, I will see you all tomorrow, so we'll finish a little bit early today. You deserve it. We should finish on a bad joke, shouldn't we? Has anyone got a bad joke? Okay. I should have a bad joke, but I think I've told you them all. What does a dog with no nose smell like? Don't know. Terrible. Okay, Vanessa says she only tells good jokes. Vanessa, tell us a good joke.
I don't have any.
Oh, so that's just your cover. Okay. Right, well, I will see you all tomorrow. Bye-bye. Make sure you got your last name. And be on the lookout for your report late on Monday, where you'll get all your grades and everything. And there is no more extensions. If you ain't done it by midnight Sunday, you ain't done it. There's good grammar for you.
So is there class on Tuesday?
Nope,
Okay.
that's exam week. So after Monday, I don't see you till the final.
Okay. Thank you.
Okay, bye-bye.
Thank you,
As you